the Asus Strix. This is the Z270i ITX from Asus. The Strix. I thought Strix was like a bad omen in Greek and Roman mythology, but maybe not. I mean, I think it'd be pretty cool if I had a motherboard that fed on the blood of humans or whatever. So we set this thing up and put it through its paces, and I'm happy to report that with the AI suite, auto overclock, it did overclock the i7 7700K processor that I use for testing to 5 gigahertz on 2 cores and 4.9 gigahertz on all 4 cores, and that's at 1.39 volts. Now that CPU will go to 5.0 on all 4 cores at about 1.3 volts, but the software errs on the side of caution and errs on the side of stability. I didn't do any testing with the negative AVX instructions or anything like that because I do know that this CPU requires a negative multiplier for the AVX instructions for maximum stability. So the AVX part of the CPU, of course, is not going to run at 5 gigahertz. But still, for a completely automatic overclock on an open air test bench, that's pretty darn good. The big feature on this motherboard, though, is that it has 2 M.2 slots. There's one just above the graphics card, so it should have plenty of breathability. There's also one M.2 on the bottom of the motherboard to give you even more M.2 connectivity. Now, M.2s do get kind of toasty. I did my testing with the Toshiba RD400. The thing comes with a removable heatsink. I think I still like the removable heatsink to be removed when you're working with an M.2 like the Toshiba RD400. Now, the heatsink does contact the M.2 on the bottom as well as the top. In fact, there's an included thermal pad that you can peel the plastic off and actually stick a thermal pad to the M.2. And I probably should do more extensive testing to see if it's better with or without the shield. But just sort of anecdotally, running the test through SpeedFan, I think the temperatures were slightly better without the shroud for the particular Toshiba RD400. But again, not super extensive testing. Now, in terms of other testing, we did do a full suite of Linux testing. We did IO-MMU testing, so you can do PCI Express pass-through if you want. I did the testing with the Radeon RX 480, and I'm happy to report I think that there were 9 IO-MMU groups. You can see the output of LSPCI showing the IO-MMU groupings. Also on the screen, you can see the IO regions for the individual IO regions that are available on the motherboard. One quirk in UEFI, you have to enable VTD and virtualization in 2 different places. So there is that. For our testing, we used a Crucial Ballistics memory. This is, basically the kit of memory that was on sale, but pretty decent. And the ballistics memory worked fine, even with the overclocking, even with the, the CPU hitting 5 gigahertz. Let's take a look at the connectors at the back of the motherboard. Now, first up in the top corner of the motherboard, this is a front panel PCI Express 3.1 Gen 2 connector. So you have to have a case that supports, your 10 gigabit per second USB 3.1 ports in order to use this connector. Disappointingly, in the box, there was no kind of adapter or anything to break it out to the old style connector, or like an expansion slot cover. Remember the old days when a motherboard would come with like a bracket that was meant to go at the back of your case to give you USB ports, because not all cases even had front panel USB. Well, this is a new generation of USB and a new generation of connectors, and I would have liked to have seen a breakout connector or something like that. Maybe there's an accessory for that, and if there is, you can link to it in the description, and I'll update the description of the video with that. Right next to that, we've got our USB 3.1 Gen 2 connectors provided by our AS Media controller, 1 Type A and 1 Type C. Then we've got our 4 USB 2.0 ports. Then we've got DisplayPort and HDMI for the built-in iGPU solution from Intel for your, Kaby Lake, Skylake, whatever you might be running. This is compatible with Skylake CPUs, of course, so your i7 6700, 6600, whatever you might be running, that works, as well as the Intel Kaby Lake CPUs. Then we've got 2 more USB 3.1 Gen 1, that's 5 gigabit per second, USB ports. And then we've got our Wi-Fi Go module, which is serviced by a Qualcomm Atheros chipset. This is a 2x2 configuration. It also has built-in Bluetooth. Then next to that, we've got our Sound Blaster 120 dB certified signal to noise ratio audio solution. It is a creative implementation of the sound card. So if that's something that you're looking for, then it's certified by Creative. It does have optical SPDIF out, as well as your standard analog audio out. And of course, there's an audio front panel connector Asus refers to the sound solution as Supreme FX, and of course it does have the fine-grade Nishikon audio capacitors, as one would expect from a solution like this. At the top edge of the motherboard, we got our first 4-pin fan header. It is DC and PWM. Then we've got our 8-pin CPU power connector and part of our voltage regulator heatsink assembly. Now there's 2 heatsinks that are associated with the CPU voltage regulation circuitry, and both of those heat sinks are not connected in any way, so there's no like thermal connection or anything like that. We've seen heat pipes on some motherboards, but this particular one does not have a heat pipe or any kind of connection there. We've got our 2 DDR4 DIMM slots, and really small right next to the power connector, the ATX power connector on the front edge of the motherboard, there are some diagnostic LEDs that you can use to figure out what the system is. The system will sort of give you some hints on, oh, the CPU is having problems or the memory is seated, things like that, with these little diagnostic LEDs that are scattered around the board. And the first grouping is there at the top edge of the board. Just below our ATX power connector is a header for an RGB strip. So if you want to put in an RGB header strip and control it from the Asus Aura software, you can totally do that. Then we got our front panel connector and our 2 SATA 6 gigabit per second ports. Then just below that, you've got your front panel USB 3.0 header. Just below the USB 3.0 header is another diagnostic LED so that you can see the readout. Now also along the front edge of the board here are individually addressable RGB LEDs that you can also control from the Asus software. So you've got a lot of different options. You can tie control into your individual music preferences, or you can also control the LEDs through software or system temperature, or according to a preset pattern, whatever that you might want to do. Then of course on the bottom edge of the motherboard, we've got our PCI Express by 16 expansion slot. This is reinforced. It's the Asus patent pending reinforced slot design. It's designed to deal with huge shearing forces from very heavy graphics cards that you might have in your system. Then right behind the front panel connectors are 2 things. One, your CMOS battery, which is got a 2-pin wire connected to the motherboard, so it's not a normal coin cell. If the CMOS battery goes bad, you're not going to be able to just go to any local store and replace the CMOS battery. You have to use the vertical one. I don't really see that as a big deal. It's a standard form factor for batteries. You just have to order it online as opposed to getting it at your local hardware store. No big deal. And then there's also a 4-pin all-in-one pump header right behind the Wi-Fi Go module. So if you've got a closed loop all-in-one, something ridiculous that you're running in your ITX world, you can totally control it from that 4-pin fan header. So with our testing and the fun stuff with this motherboard, what's the verdict? It's a competent motherboard. It has a nice set of features for what it is. It has 2 M.2 slots. Honestly, the 2 M.2 slots is the biggest deal for me because, I can do lots of really horrible things like convert the M.2 back into PCI Express, which I'm sure that is not exactly an on-label use. It's definitely an off-label use. But I can totally convert the M.2 slot above the graphics card into a PCI Express slot for an internal peripheral if I really want to, and still have my M.2 for storage on the bottom of the motherboard. I think that should make its way into a build or a special project or whatever. If I can convince somebody to sponsor it, I'm not going to ask the fans to sponsor that. That would be silly. So that's pretty cool. I also like that it was really stable and seemed to be well supported in Linux. Booting into Linux and checking the peripherals and everything with Fedora 25, everything worked out of the box. The sound worked, even the Wi-Fi Go module, because the Qualcomm chipset, I was really worried about that. A lot of other motherboard vendors have picked the Intel chipset over Qualcomm this generation, but the Qualcomm chipset worked fine, and the Bluetooth seemed to be working fine as well, and that I could enumerate devices, join wireless networks, that sort of thing. It is a 2x2 configuration, so we're not talking about like super crazy performance on the Wi-Fi module here, but it did show up in a separate IO-MMU group, so you could pass that through to a virtual machine if you want to. With the advent of Linux kernel 4.10 and virtual GPU, I'm really, really hoping that vendors other than Intel will support, the SR-IOV extensions for graphics cards, so that graphics cards like the RX 480 and not necessarily like a Fire GL or something expensive like that will support GPU pass-through to Windows virtual machines under Linux, but it will actually share with the host operating system. So I'm really hoping we see driver support like that. The motherboard supports it. The motherboard for its part, because it's a lot, all your hardware has to support it and has to support it properly. And I'm happy to report the hardware, the motherboard, is doing what it's supposed to as far as the IO-MMU groups go, and as far as that type of thing go. So that's good as well. And of course the sound card worked under Linux. Sound Blaster, it's a pretty similar implementation to what we've seen. It's just assembled with a little bit better components so that you get that 120 dB signal to noise ratio, and it is Sound Blaster certified if that's important to you. So Supreme FX, Creative Labs, if that's your thing, there you go. that's pretty much it. There's not really a lot else to say. It's an ITX motherboard with 2M.2. What else do you want to know? If you picked up one, or you're thinking about picking up one, or you want to chat with other forum members about their thoughts on this, or see any details, or if there's an update, you can better believe that you'll find it on the forums at Level 1 Techs. I'm Wendell, I'm signing out, and I'll see you there.